Greetings, everybody. I need to make a response to my initial prompt, my initial question to you about if I made a mistake in setting up this difference quotient and where it was. Okay, so in my original prompt, I had said that I want to calculate the difference quotient for this function. Okay, and that here's what the difference quotient is right here: f of x plus h minus f of x over h. And then I set it up like that. And that's, for the most part, that's as far as I took it. And then I ask you, where's the mistake? So the mistake is like this. See how the difference quotient is f of x plus h minus f of x over h. Okay? Now if you dissect what I have right here, this much of it is f of x plus h. Okay? And then this much of it is f of x. And then there's that minus between them right there. What I didn't write down, what I didn't indicate in my original prompt, was that this minus has to apply to that entire function f of x, whatever it might be. And if it has several terms in it, that minus has to apply to all the terms. So I should have put a parentheses or a bracket around it to indicate that that minus does apply to all of that. That was what I missed. That was the mistake that I had in my setup. Okay, so let's say that we go from there, and I'm going to put a parentheses around this too as a result. How would we work it from that point? Well, so I kind of have to follow the order of operations with this. In order to work this out and reduce it to smallest terms, I would have to apply the exponent and then multiply by 3. So first I apply the exponent. What is x plus h squared? So, well, how do we square something? We square something by multiplying it by itself. So it's going to be like x plus h times x plus h. And we use something called FOIL multiplication to do that. And you'll get x squared plus xh plus xh plus h squared. And then those two middle terms are like terms, so that's x squared plus 2xh plus h squared. And that's what you see right here. So the exponent's been applied. Next, I would have to multiply by this 3. So that 3 is going to multiply whatever this turns out to be. It's 3 times this, whatever that is. And so we might look at it like, well, so what we need to do is multiply 3 like that, multiply 3 like that, and multiply 3 like that. So we get 1 minus 3x squared minus 6xh minus 3h squared. Okay, like that. And remember when I said this minus applied to this whole thing, and that's what I missed in my original prompt? I didn't put these parentheses to indicate that. So at this point I'd have to say, well, that negative applies. So I'm going to take the negative or opposite of all of that, or I'm going to distribute a negative 1. What I'll get is a minus 1, and then if I take the opposite of negative 3x squared, I'll get positive 3x squared. Okay, so I get to this point, and then I notice a lot of things cancel out of it. I have a 1 and a negative 1. I have a negative 3x squared and a positive 3x squared. Okay? And so those cancel because they're opposites. And I'm left with negative 6xh minus 3h squared over h. So one more cancellation that we make in the difference quotient is the h's. Okay? Another mistake that could happen is that you just cross out those h's right there. But then you ignore this one. You ignore the fact that both of these terms individually get divided by h. So it might be more proper, so that we don't make a mistake, to factor out an h. Did I factor this correctly? Let's see. How could you check if you factored something correctly? You could multiply back together and see. So what's h times negative 6x? Negative 6xh. What's h times negative 3h? Negative 3h squared. So I factored it correctly because I check it by multiplying. But here I'm looking at h divided by h, which cancels, okay? H divided by, a number divided by itself is going to be 1, and so You got a 1 right there, which is essentially does not affect what we get. All right. So that leaves us then with negative 6x negative 6x minus 3h. Okay, and then I'm done at that point. All right. So one final thing I'll say is that the difference quotient is something that we cover in the class, and it's something I need to get you to learn how to do. But it's not just like some exercise where you're jumping through hoops to show me that you can do something. This is an extremely important thing in science and engineering. It's what is used mathematically to measure rates of change. You see, in the physical world, everything is changing, but things are also all connected together. So change in one thing almost always causes change somewhere else. And when two things change together, we say there's a rate of change between them. And so much of science and engineering is based on a rate of change. You're familiar with a rate of change. If you ever drive, the speed of your car is a rate of change. If you say you drive 60 miles an hour, that means if an hour were to go by, you could travel 60 miles. You know, if you kept at that speed. That's a rate of change. And the difference quotient is the thing, what you use to measure that mathematically. So that's why we put so much emphasis on it in our class. If you go beyond this, if you make it to calculus, if that's what you want to do, and beyond, you'll be seeing lots more of the difference quotient and rates of change of all different kinds.